Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 10, Lesson 6 on the area of a circle. Now, in our last lesson, we looked at the circumference of a circle, and we looked at how it depended on this new number that we introduced last time called pi. All right, so that's where we're going to start. We're going to start by looking at the circumference of a circle again, okay? And then we're going to move into how you measure the area, right, the number of square units of whatever, square centimeters, square inches, square feet, that lie within a circle. You are most certainly going to want to have your calculator today. We're going to, like one of our last exercises is going to be messy. Just warning you right now, it is going to be a decimal mess. But using your calculator will obviously make that a lot easier. So let's get into it right away. Right? Recall that the circumference of a circle is the distance around the circle. Imagine unrolling the curve and then measuring its length. And remember, the circumference, right, of a circle, right, a circle with a radius r and a diameter d has a circumference of pi times the diameter, or, and we never really used this particular formula last time, 2 times pi times the radius. Now remember, the only reason that we would have this formula is because the diameter is simply 2 times the radius. So throwing that 2 factor in there means that we wouldn't really have to convert the radius to a diameter, you know, by multiplying by 2, which is no big deal. You know, I mean, obviously you can do that. But, you know, in letter B, where we're given a radius, I'm going to eventually just use this formula. It's a nice one to kind of get used to, although most of the time when people find the circumference, they do use just pi times the diameter. So let's do a couple circumference problems. Now remember, you're talking about the distance around a circle, right? The distance, feet, miles, inches, centimeters. Exercise number 1. Calculate the circumference for each of the following. Round to the nearest tenth. All right, so this is literally just plugging numbers into formulas, okay? The diameter is 10 inches. So the circumference of a circle is pi times its diameter. So the circumference is pi times 10. And again, for that, we definitely want to use our calculator. We'll take the pi button, we'll multiply by 10, and we'll get our circumference. Now we want this to the nearest tenth, so that's going to be 31.4 inches. Right? Whatever the distance units are on the diameter become the distance units on the circumference, because the circumference is a distance, right? I mean, imagine, as hard as this is, imagine walking all the way around the Earth. That would be a long way to walk, right? But you would be walking a particular distance. You wouldn't be walking an area or a volume or anything like that, but you'd be walking a particular circumference of that sphere that is the Earth, right? But when you walked around it, it would actually be in a circle. All right, let's take a look though when we have a radius of 9 centimeters. All right, that's easy enough. Again, there's nothing wrong with taking the 9 centimeters, multiplying it by 2, getting a diameter of 18 centimeters, and then doing what we just did. But you can also use the circumference formula that says do 2 times pi times the radius, in which case the circumference, 2 times pi times the radius. We could literally just put it right like that in our calculator if we wanted. 2, whoop, I don't need the second button, Kirk. It's not going to let me. There we go. 2 times pi. We could use the 9 just in parentheses. And the circumference is going to be 56.4 centimeters. All right. The circumference formula is exceptionally easy, right? And it all came from the fact that the ratio of the circumference divided by the diameter was this magical number pi, 3.141592, etc. All right? 3.141592. About 3, right? All right. Now what we want to do, though, is explore how to calculate the area that lies within a circle, because that is exceptionally important in the real world. So let's get into it. All right. Now we can also measure two-dimensional space inside of a circle, or the area of a circle. We still want to calculate the number of squares of a certain size that fit within it. So let's actually approximate the area that lies within a particular circle. Exercise number 2. A circle with a radius of 3 centimeters has been placed on top of square grid paper where the squares are 1 centimeter on a side, so are square centimeters. We're going to estimate the area within the circle, all right? Now let's talk about how we're going to do that, right? So again, I just want to be very clear. Every one of the squares that you see here is a square centimeter. Literally, that's the way I designed the worksheet. If you took out a ruler and your teacher didn't enlarge or shrink down the worksheet, right, then each one of these squares is a centimeter by a centimeter, and you can see that the radius is 3 centimeters, right? The distance from the center of the circle out to any point on the circle is 3 units. 1, 2, 3. Just wanted to establish that. Now, you can obviously tell that there's a lot of squares within the circle that are whole squares, like that's a whole square, that's a whole square, that's a whole square. Then you can see that there are some of them that are pretty close to whole squares, like, you know, that one up there, that one up there, this one. Like they're pretty close to whole even if they're not quite. And then there are some that are closer to, let's say, a half of a square than a whole square. That might be like this one, this one, this one. There's some that like are so small we wouldn't want to count, like this little like portion down here. You know, I don't want to be like, oh, maybe that's a quarter of a square. It's not, by the way, it's not even close to that, all right? So here's what we're going to do. In letter A, I'd like you to write a W in any whole square or nearly whole square and then count how many you have. All right, so take a look at the picture and write a W in any square that is either completely whole or pretty close to whole, like these guys up here. Pause the video now and go ahead and do that. All right, well, what do we have? There they are, right? There are all our whole squares, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And then what happens is those same 12 are doubled down here, so we've got 24 square centimeters, right? Now, we're still missing a lot, right? We're missing all these half squares. So that's letter B. Take a look. Write an H in any half or nearly half square. Then count and divide by 2. All right, why don't you go ahead and do that? All right, well, let's get them in there, right? So there are all of our half squares. Those I did in green. So we got one there, one there, one there, one there. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 half squares. Now, keep in mind, right, I have 8 half squares. So that means I'm going to get an additional 4 square centimeters, right? Now, I'm missing a little bit of area, right? I mean, there's definitely a little bit down here that I've missed, a little bit down here that I've missed, etc. But again, I don't want to even take those into account. So I can say that the total area, the total number of squares, centimeters that lie in here, is pretty well approximated by 24 plus 4, or 28 square centimeters, right? I can do that. Now, granted, I don't want to have to do that every time. That would be exceptionally messy if I had to do that every time to figure out the area of a circle, right? It would be inefficient. It would be really bad if I had to, let's say, had like a really kind of ugly radius, like a fractional radius or a radius with decimals in it or something like that. So not surprisingly, there is a formula, just like there is for circumference. There is a formula that tells us exactly what the area of a square is. And let's take a look at that formula. All right. Just like the circumference of a circle, there's a formula to calculate the area of a circle, and that formula involves the number pi, that 3.1415 thing. And it's this simple. The area is pi times the square of the radius. That's not surprising that the radius is being squared. Now, don't get me wrong, maybe it's surprising that it's the radius and not the diameter, but it's the radius, all right, the distance from the center out to any point on the circle, all right. Not surprising it involves pi, given that the circumference involved pi. Not surprising it involves the radius squared, because area is square units, right? And it would be a little weird if we didn't have a dimension times a dimension, right? I mean, think about like the areas of everything else. The areas of a square, a rectangle, a triangle, they're always one length times another length. The thing here is it's literally the two lengths are the same length, if there are. So it's like literally pi times r, right? Now, let's use this formula. Exercise number 3. Given the circle from exercise number 2, find its area, A as an expression involving pi, and B as a decimal accurate to the nearest tenth, and then we're going to compare that to our answer in exercise number 1. All right, so in exercise number 1, we had a circle with a radius of 3 centimeters. So let's first find out its radius as an expression involving pi. Well, the formula is pi times the radius squared. So our radius is 3. 3 times 3 is 9. Now, let me just write that down and then step back for a second. All right, I know this is going to sound funny, but even though the formula is always written as pi times r squared, we should never leave our answers as pi 9, okay? The reason being that honestly, it just looks funny. It just does, right? You would never, in an equation, right? Think about an equation that looked like this, right? Think about that for a moment. Think about how weird it would look if somebody wrote this equation instead. x9 plus 1 equals 25, right? Are they the same thing? Well, this is 9 times x, this is x times 9. Sure, they're the same thing, but we just don't write it this way. We write the number first and the variable second. Now, in this case, they're both numbers. Pi is a number and 9 is a number. But the convention is always to write it with the pi second. So you'll see me every time I write it out in what's called in terms of pi, involving pi, I will always have sort of the radius squared first and then the pi second. Now, what does this actually predict our area to be? Let's bring this up over here and let's just type it in. This is easy. 9 pi, I can literally just type it in just like that. I don't know why that just happened. Come on, there we go. And I'm going to hit enter. And that gives me my area to be 28. It says to the nearest tenth, 28.3 square centimeters. Remember, we always have to have units of area, right? Area units. Don't tell me ever that area is 28.3 centimeters. That just doesn't make any sense. I'm counting the number of squares that lie inside of something, right? 28.3 square centimeters. Now, how does that compare to our estimate in exercise number 1? Well, let's go back. Look at that. Our estimate in number 1 was 28 square centimeters. We just got 28.3, right? And that might be because, we were a little bit low, right, with our 28. Our 28 was a little bit smaller than what it should have been, which is 28.3. And maybe that 0.3 is these little areas here that we didn't quite take into account, right? And that would have been, again, that would have been tough to do from an estimate perspective. But that's it. That's how you calculate the area of a circle. You take the radius, you square it, right? Multiply it by itself. You then multiply by the number pi, and that tells you how many square units fall within a circle. Now, I've given you no basis for this formula other than it fits with what we saw in that last exercise where we did the estimate, okay? In high school level geometry, you will see how the area formula of a circle comes directly from the area formula, from the circumference formula of a circle. So you can take that circumference formula, circumference equals 2 pi times the radius, and you can actually manipulate it to figure out the area formula. But we're not going there right now. Our main purpose in Math 7 is to expose you to the formula, have you use the formula, and get comfortable with it. So let's do that. Let's do a bunch of problems. Here we go. Exercise number 4. For each of the following pieces of information, find the area of the circle. First, state it in terms of pi, and then round to the nearest tenth. All right, so the area formula is pi times r squared. Let's do one together, and then we're going to have you do b and c by yourself. All right, and then we'll take a look at somewhere where the diameter is given. All right, let me just bring it up here. I'll keep reiterating that formula time and time again. Let's do letter A together. All right, so the area is pi times r squared. So I'm going to put 10 in for my radius. Of course, 10 squared is 100. So this is my area in terms of pi. Now, if I want my area rounded to the nearest tenth, that's when my calculator becomes very, very handy. I'm going to have 100 times pi, enter, and I get 314. I want this rounded to the nearest tenth. You know, what we round to really would depend on our application. Sometimes we would want to round to the nearest whole number. Sometimes we might want to round to the nearest hundredth, thousandth, etc. But in this problem, we're just going to be rounding to the nearest tenth. Now, you know, a lot of math teachers would say this is the exact answer, 100 pi. And this is an approximate answer, 314.2. In the real world, of course, we are always going to be using an answer like this in some way. We're going to round it at some point, okay? And again, hopefully in the real world, you would know how accurate you needed that area to be. Oftentimes, you don't need that area to be any more accurate than the nearest square foot, but sometimes you might. All right. Let's have you do letter B and letter C on your own. And I know letter C might look a little frightening because it's got a radius that's fractional. But remember, when you square a fraction, right, just do 3/2 times 3/2. All right, multiply the tops, multiply the bottoms. That's how you multiply two fractions. Multiply the tops, multiply the bottoms. Okay, pause the video now and see if you can do both B and C, come up with the areas in terms of pi, and also round it to the nearest tenth. Pause the video now. All right, let's go with a radius of 7 inches. In this case, I'm not going to keep writing down the formula. That'll give me a little bit of extra space. Area equals pi times r squared. 7 times 7 is 49. So in terms of pi, the area is 49 pi square inches. In terms of it in a decimal representation, obviously, nothing really tricky about doing that. And we get 153.9 square inches. All right. Now, fractions make everything more difficult. They just do. Fractions and decimals. You know, I love whole numbers. I'm sure you love whole numbers, but you know, a lot of times we have to deal with fractions. So let's do it. All right, radius equals 3/2. Here we go. The area equals pi times 3/2 squared. Now, maybe just down here, right? 3/2 squared is going to be 3/2 times 3/2. And with fractions, right, you multiply their numerators, you multiply their denominators, so you get 9/4. And what I would hope that you notice here is that when we square a fraction, we do that by squaring the numerator and squaring the denominator, right? That's all we do, right? It's easy enough. 3 times 3 is 9, 2 times 2 is 4. We just square both of them, all right? So I'm going to actually get rid of this just so that I can save myself a little bit of room. Hopefully this will erase. Yes, it does. For once, technology works. So my area in this case will be 9/4 pi centimeters squared. Now, this can also be a little bit tricky to put in the calculator, but your calculator knows order of operations. So 9/4 I can put in as 9 divided by 4, and then I can do times pi. And that will give me an area of 7.1 square centimeters, rounded to the nearest tenth. 7.1. All right. Let me move this out of the way. Now, remember in our last lesson, we were doing a bunch of circumference formulas, or circumference problems. And we mostly gave you the diameters, right? Because the circumference at that point was just pi times the diameter. But then all of a sudden, I snuck some in where I gave you the radius, right? And you had to take the radius and you had to multiply by 2 to get the diameter. Then you took the diameter and you multiplied by pi to get the circumference. With the area formula, dependent on the radius, not the diameter, right, the radius, not the diameter, then what you oftentimes will do, or what oftentimes happens, is you end up having problems where you're given the diameter. And you have to watch out, because it would be very easy to be like, oh, I'm just going to take my diameter, square it, multiply by pi, and get the area. But that's not going to work, because the diameter is too big by a factor of 2. So in this case, we have to go in the opposite direction, and we have to divide by 2 first, then square, then multiply by pi. But it's easy enough, right? So I might say my radius is 1/2 times 8, which is equal to 4 centimeters, right? So now my area is going to be pi times 4 squared. 4 times 4 is 16. So my area is 16 pi square centimeters. And in terms of the nearest tenth, we can now just say 16 pi, enter, and we get 50.3. Forgot what I was rounding to. 50.3 square centimeters. All right. Now, of course, I left you with two that are more challenging, one with a decimal, one with a fraction. It's going to be okay, all right? Pause the video now. Remember, you first have to find out what 1/2 of each of these is. Once you've got what 1/2 is, then you've got the radius and you can substitute it into the area formula for a circle. Pause the video now and see if you can work through these two. All right, I imagine that you probably found E easier than F, just because fractions, you know, I mean, decimals aren't great, but they're not terrible to deal with. In fact, right, the radius here is going to be 1/2 times 14.8, or 14.8 divided by 2. So the radius ends up being 14.8 divided by 2, 7.4. You can do that in your head. Awesome. So now the area is going to be pi times 7.4 squared. Now I don't want to do 7.4 squared in my head, right? So I'm going to come over here. I'm going to do 7.4. I'm going to use my squaring button, or you could just do 7.4 times 7.4. That's 54.76 times pi square meters. So this is my exact answer. And yeah, it's kind of weird because it's mixing, you know, decimals with pi and stuff like that. That's okay, right? Now, if I want to get it as a rounded answer, I can actually take my calculator, right, where my 54.76 is still there, and just multiply that answer by pi. So now my area is 172, and technically it's 0.0 meters squared, right? So if I'm rounding that to the nearest tenth, okay, and this is kind of a tricky rounding scenario, right? I've got 172.03, right? So I'd be looking at the 3, and the 3 would be telling me don't do anything with the 0, but watch out. Because if you write this down as 172 square meters, that implies that you've rounded it to the nearest whole square meter, right? 172.0, if it says round to the nearest tenth, you gotta have a tenths digit there. Caught that? If it says round to the nearest tenth, you must have a tenths digit. All right, let's take a look at probably by far the hardest problem of the day maybe, right? Where the diameter is 5/8 of an inch, because I gotta figure out what half of that is, all right? And that probably is the hardest part. In fact, right, I want my radius to be 1/2 of 5/8. Well, I mean, this is just multiplying the fraction 5/8 by the fraction 1/2. Well, when I multiply two fractions, I multiply their tops, I multiply their bottoms. So the radius in this case is 5/16. 5/16 is 1/2 of 5/8. It's that simple. You know, add 5/16 to 5/16, you'll get 10/16, and that will reduce down to 5/8. All right, now let's plug it into the area formula. Let me get rid of this. I think I'm definitely going to need that space. So my area is now pi times 5/16 squared. Now remember, when I square a fraction, I square the top. Actually, I'll put the pi out here. I square the top, which is going to be 25, and I square the bottom. Now 16 squared, that might be a perfect square you don't know. And if it's not one that you know, you just plug it into your calculator and you find it. So in its exact form, the area is 25 divided by 256 times pi square inches. All right, and that can be very tricky for kids, right? Because first, you've got to find what 1/2 of 5/8 is. And that all by itself is confusing, right? But trust me, like, it's easier to think about it that way than thinking about what is 5/8 divided by 2. That's definitely confusing. You know, if I had 6/8 divided by 2, well, that would be 3/8. But 5/8 divided by 2, that's more confusing, right? So I would just multiply by 1/2. Then, of course, squaring a fraction can be a little tricky. Square the top, 25. Square the bottom, 256. And now I need to get that area in its decimal form. This is going to be a very small area. Very small area. I probably should have had you round this one to more decimal places. So I've got 25 divided by 256 times pi. And that gives me an area rounded to the nearest tenth, mind you, of 0.3 square inches. Teeny tiny area. And that makes sense because honestly, the radius is quite small, right? 5/8 of an inch is a radius that's less than an inch, right? The numerator is less than the denominator. It's actually a radius that's pretty close to 1/2, all right? And then when we square it, it gets even smaller. All right, but really, at the end of the day, there's nothing all that new here other than the fact that I'm just taking these radii, I'm substituting them into this formula, multiplying them by themselves, right? Squaring them, and then multiplying by the number pi. Let's take a look at one final problem, which brings us back to some work that we did with scaled drawings recently. Let's take a look at exercise number 5. An architect draws a circular fountain at a scale of 2 centimeters to 5 feet. On the drawing, the fountain has a radius of 6 centimeters. Find its actual area to the nearest square foot. All right, I'd like you to play around with this. Pause the video now and see if you can find out the actual area of this fountain to the nearest square foot. All right, let's do it. Well, the first thing I'd like to know is what the actual radius is, right? So I don't know what the actual radius is. I know on the picture it's 6 centimeters. That I know for certain, right? So I'm going to set up that proportion, right? I'm going to say the radius is to 6 centimeters as 5 feet is to 2 centimeters. Right? Remember when we did scaled drawing work just a few lessons ago, right? So what I'm really looking for, divided by its length that's been scaled, compared to, right, the real world distance and its scaled length. Now, of course, I can just multiply both sides by 6 in order to isolate the r. Okay. 2 goes into 6 3 times, and I find that my actual radius of my fountain is 15 feet, which kind of makes sense, right? I mean, you know, here I've got it 6 centimeters on the picture. Every 2 centimeters is worth 5 feet. I've got 3 of those, so I've got 15 feet of radii. Okay, now I can do the area formula, right? The area formula is going to be pi times 15 squared. And because they want it to the nearest square foot, there's actually no reason for me to figure out 15 squared. I can just do this, right? And that immediately tells me that the area is 706.8, etc., rounded to the nearest square foot, 707 square feet. And that's that. Now again, right, the reason that I didn't have to figure out what 15 squared was, which was 225 for the record, is that I can just type this into my calculator. I want my answer to the nearest square foot. I don't need it in terms of pi. I don't need to write my answer expressed in terms of pi. This is the real world. I want to know what the area of the fountain is in square feet. I don't need a pi sitting there, okay? And that's 707 square feet. All right, let's wrap this up. So today, what we saw was the area formula for a circle, right? And not surprisingly, it contained 2 things. One, the number pi. And that's not a surprise because the circumference formula for a circle also involved the number pi, okay? The other thing that shouldn't be a surprise is that it included, right, the radius squared. Not so much the fact that it included the radius itself, because it could have included the diameter, right? I mean, the circumference formula included the diameter. But the fact that it was the radius squared. It was a dimension, the radius, times another dimension, also the radius. And if you think about every area formula you've ever worked with, length times width, base times height, all of the area formulas you've ever worked with have always had some length times some length. Even if you think about the area formula for a square, right? There you'd have side times side, or side squared, right? The difference between the area formula for a square and the area formula for a circle, honestly, is the number pi in a certain sense. Anyhow, we'll get more work with the area formula of a circle as we move through the final few lessons of this course. And let me be very clear, you'll be using this formula throughout all of math. It's a very, very important formula. You'll see it time and time again, a lot in geometry, but you'll also see it in Algebra 1, Algebra 2, pre-calculus, calculus. You will see the area formula for as long as you stay in math or any technical field, because a lot of things we deal with in the real world are circular. Whether it's the cross-section of a pipe, or the cross-section of like a cylindrical Coke can, or something like that, we need to know those areas. So we need to know the area formula for a circle. All right, well, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.